Well, in the words of Will Ferrell in the movie Elf when he ran into the coffee shop, congratulations, you did it. You made it to the last video for Math 126. It's the fourth of the final videos for section 10.7. It's our fourth type of partial fractional decomposition. So what did we have? First case, distinct linear factors. Second case, linear factors that repeated. Third case, irreducible with a quadratic. So what do you think the fourth type is? That's right, irreducible with a quadratic that repeats. And so it's just kind of all building on itself. So we have a repeated, irreducible, quadratic factor. And so this way to solve this one is basically a combination of type 2 and type 3. So type 2 is what? If we had x minus 1 to the third, we used x minus 1, x minus 1 squared, x minus 1 to the third. Now if we have a repeating quadratic that's not irreducible, so let's say x squared plus 1 to the third. We'll have x squared plus 1, x squared plus 1 squared, x squared plus 1 to the third. So it's really just combining those two different styles we've already done. So let's say, for example, I have 2x squared. So again, partial fractional decomposition of this guy. 2x squared minus x plus 8 all over x squared plus 4 squared. So the other thing I'll point out, we've done nothing with the numerators, right? So don't worry about factoring these. Don't worry about doing anything with them. Just leave them alone. Leave the numerator alone. All that's there for really is the comparison at the end. All right. So this one has none of the linear factors. It has a quadratic, x squared plus 4, that doesn't reduce, and then it repeats. It happens twice. So we get what? When we had the quadratic, it's ax plus b over the first one, x squared plus 4, and then repeat it. So now use the different variables. Cx plus d over x squared plus 4 squared. So you can see how these things would get really ugly in a hurry depending what your factors were. If I had, for instance, an example that had x minus 1 squared, x squared, let's do that one, plus 4 to the third, we're going to have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 different letters. We're using up half the alphabet just to expand this thing. So in a hurry, these things could get real ugly. We're keeping it nice here. We just have the 2. Same idea as we did before. Multiply by x squared plus 4 squared, the LCD. So x squared plus 4 squared, x squared plus 4 squared. On this side, all cancels out. So you get 2x squared minus x plus 8. One of these cancels with one of these. So you get ax plus b times x squared plus 4 plus both of these cancel out. So cx plus d. So now when you break this whole thing out, when you FOIL it, you end up with ax to the third plus bx squared plus 4ax plus 4b. And then these guys still plus cx plus d. So if I combine my x to the third term pieces, that's just ax to the third. My x squared pieces, just plus bx squared. My x pieces, I have 2 of them. So 4a plus c times x. And then lastly, 4b plus d as my constant piece. So again over here, 2x squared minus x plus 8. So do my comparison, that means what? A, I have no x to the third term. So that means A has to be 0. So if A is 0, this whole piece is 0. So now what do I have? Bx squared, that means B has to be 2. It's the only way both of these sides can be equal. So if B is 2, that means this guy is 8. So D plus 8, because B was 2. Now I have what? This was 0, so it's just C times x, which means C has to match up with this one. So C has to be a negative 1. And then lastly, 8 plus D has to be equal to my constant over here, 8, which means D is also 0. So the only pieces I have left, and so you can see, hopefully that's how nicely it works out. Starts out a mess. You got to do all the algebra, all the foiling, all the multiplication of binomials, but then hopefully things work nicely for you. So no A piece, no D, so just plug them back in. So we have what? This original is equal to A, which was 0, plus B. B is 2. So 2 over x squared plus 4, plus C is negative 1, D is 0, so it's just negative x over x squared plus 4 quantity squared. And that's it. So nothing more tricky than that. Once you find the answers for your variable pieces, plug them back into the original decomposition that you had, and there you go. So that's it. It's a lot of hours we spent together going through all this different math for Math 126. Hopefully you guys got something out of this. I look forward to seeing you again in the videos for 127, maybe even 181. Best of luck to you in all your future endeavors and all your future math classes. Thank you.